What if the greatest discoveries of science weren't made in laboratories or observatories, but hidden in plain sight, painted on cave walls, carved into ancient temples, or woven into the brushstrokes of Renaissance masterpieces? Long before telescopes peered into the cosmos or microscopes revealed the building blocks of life, artists across the ages captured glimpses of reality that defied the understanding of their time. These creators, guided by nothing more than keen observation and unshakable intuition, left behind clues, astonishingly accurate depictions of celestial events, natural phenomena, and even medical truths that wouldn't be proven for hundreds, sometimes thousands, of years. Today, we're unraveling the secrets they never knew they were preserving. Picture this: a prehistoric artist crouched in the flickering light of a torch, tracing the outline of a wild beast onto a cave wall. To them, it was just a scene from daily life. But what if that same image held a hidden message, a record of a comet streaking across the sky, or the precise anatomy of an animal science wouldn't dissect for millennia? Or consider the intricate patterns in medieval tapestries, dismissed as mere decoration, yet mirroring the fractal geometry of nature centuries before mathematicians gave it a name. These aren't just coincidences, they're proof that art and science have always been intertwined, two languages telling the same story of human curiosity. This journey isn't just about admiring old paintings or deciphering ancient symbols. It's about rewriting the timeline of discovery. How did artists without formal training or tools sketch the rings of Saturn before telescopes existed? Why do Renaissance paintings contain startlingly accurate depictions of blood circulation, decades before doctors mapped the human body? The answers lie in the quiet genius of observation, the act of seeing the world so deeply that truth bleeds onto the canvas. So let's step into the shadows of history, where art becomes more than beauty. It becomes a time capsule waiting for science to catch up. What you're about to witness will challenge everything you thought you knew about the past and the extraordinary minds who painted the future. Long before modern instruments could measure the heavens or dissect the smallest organisms, ancient artists achieved something extraordinary. They recorded the unseen rhythms of nature with nothing but their eyes and hands. Take the cave paintings of Lascaux, France, created over 17,000 years ago. Among the vivid depictions of bison and horses, researchers found clusters of dots that seemed random at first. But when compared to star maps, these dots match the constellation Taurus with uncanny precision. How could prehistoric people, without charts or calculations, map the stars so accurately? The answer lies in generations of patient observation, night after night, season after season, turning the sky into a living storybook. This wasn't limited to Europe. Halfway across the world, the Aboriginal people of Australia painted celestial events on rock walls tens of thousands of years ago. One depiction, known as the emu in the sky, uses the dark patches between the Milky Way stars to outline the shape of an emu, a pattern modern astronomers now recognize as interstellar dust clouds. Even more astonishing, the painting's alignment with the emu's breeding season suggests these artists didn't just see the stars, they wove them into a calendar, linking cosmic patterns to life on Earth. Then there's the Temple of Denderer in Egypt, where a 2,000-year-old ceiling carving shows what scholars once dismissed as mythological symbols. But when historians overlaid the carving with modern star charts, the so-called myths revealed the precise positions of planets like Mercury and Venus, positions that wouldn't be mathematically calculated for centuries. These artists weren't just decorating walls, They were creating celestial snapshots, preserving moments in time with a rigor we'd associate with scientific instruments today. What's truly humbling is realizing how much these ancient observers noticed without the tools we take for granted. A medieval tapestry in Norway, woven long before the discovery of fractals, captures the repeating spiral patterns of fern leaves, a design mathematicians wouldn't formalize until the 1970s. Or consider the Munch pottery of Peru, which depicts the hunting strategies of octopuses with such detail that marine biologists now study them to understand behaviors never before documented in the wild. Time and again, art has served as humanity's first laboratory, a place where curiosity and craftsmanship collided to reveal truth science would later confirm. So the next time you see an ancient painting or carving, look closer. Those strokes and lines might be more than art. They could be a message across time, waiting for the right moment to be understood. And if these creators could see so deeply without our technology, what does that say about the power of simply paying attention? Perhaps the greatest tool for discovery isn't a device at all, but the human mind, trained to notice what others overlook. Celestial alignments hidden in prehistoric art reveal just how deeply our ancestors understood the night sky, not as distant specks of light, but as a living map woven into their daily lives. The Lascaux caves, with their 17,000-year-old paintings, are more than galleries of ancient wildlife. Between the charging bulls and galloping horses, clusters of dots curve across the stone in patterns that mirror the Pleiades star cluster. Known across cultures as the Seven Sisters, this group of stars held sacred significance from Greek mythology to indigenous Australian Dreamtime stories. Yet here, in the flickering torchlight of the Ice Age, someone recorded their position with startling accuracy. What's even more remarkable is how these star maps served practical purposes. For the creators of Lascaux, the Pleiades weren't just pretty lights. Their rising and setting marked critical turning points in the year, signaling the start of hunting seasons or the migration of herds. Modern researchers found that the cave's star-like dots align with the cluster's position as it would have appeared 15,000 years ago, a fact confirmed by astronomical software. This wasn't random doodling. It was a deliberate, generations-long project of celestial record-keeping, etched by people who relied on the sky's rhythms to survive. But the story doesn't end in France. In Spain's El Castillo cave, red discs painted on the ceiling follow the same pattern as the star Vega, one of the brightest in the northern sky. And in Turkey, the world's oldest known temple, Göbekli Tepe, features carvings of scorpions and foxes that scholars now believe correspond to constellations like Scorpius and Vulpecula. These artists didn't have written language or calculators, yet they mapped the heavens with a precision that rivals early astronomical charts. How did they do it? The answer lies in patience and purpose. Unlike modern astronomers peering through telescopes, these ancient sky watchers spent lifetimes tracking subtle shifts in the stars' positions. They passed knowledge orally, refining their understanding with each generation. A single dot on a cave wall might represent decades of observation, a collective memory of where a star appeared during the spring equinox or the first frost. This was science in its purest form, rooted in necessity, honed by repetition, and preserved in art. Perhaps the most humbling realization is that these early astronomers saw connections we've forgotten. The Aboriginal people of Australia, for instance, didn't just chart stars. They wove them into songs, each melody encoding the movement of celestial bodies. In Namibia, ancient rock art depicts the moon with craters visible only during specific phases, details impossible to see without careful, sustained study. These works challenge the assumption that scientific discovery began with formal institutions. Long before observatories or textbooks, humanity's first scientists were artists, their canvases lit by firelight and starlight. So the next time you gaze at the night sky, remember, you're not just looking at stars, you're seeing a storybook written across generations, one that began with a hand tracing dots on a cave wall, bridging the gap between Earth and cosmos. And if these ancient artists could decode the heavens with nothing but their eyes and intuition, what else might we rediscover by seeing the world as they did, not just with tools, but with wonder? Deep in the temple of Hathor at Denderer, a carving on the wall has sparked debates for decades. A strange, bulb-like object with what appears to be a twisting filament inside, encased in a vessel that looks eerily similar to a modern light bulb's glass enclosure. To the untrained eye, it's hard not to see something resembling ancient electrical technology. Mainstream archaeologists argue this is simply a symbolic representation of a lotus flower, a sacred plant in Egyptian mythology, emerging from its stem. But the precision of the carving, the way the filament coils like a snake, the bulbous shape cradled by what could be interpreted as an insulating base, has led some to wonder if the artists were depicting something far more advanced. The so-called Denderer light controversy hinges on a fundamental question: when does artistic symbolism cross into inadvertent documentation? The lotus explanation makes sense in context. Egyptian art frequently used plants to represent creation and rebirth, and the temple walls are filled with similar motifs. Yet the level of detail in this particular carving stands out. The filament isn't just a straight line, it mirrors the serpentine form of an electric arc, and the surrounding figures seem to interact with the object in ways that suggest more than ritual symbolism. One priest holds a knife near the base, as if disconnecting a power source, while another appears to kneel in reverence. Could this be a depiction of a forgotten technology, or are we projecting modern assumptions onto an ancient metaphor? Interestingly, the ancient Egyptians did have access to materials that could theoretically support electrical experimentation. The Baghdad Battery, a clay pot found in Mesopotamia and dated to roughly the same era, contained traces of acidic residue and copper, leading some to speculate it functioned as a primitive voltaic cell. While most scholars dismiss this as coincidental, it raises an intriguing possibility. What if artisans and priests, observing natural phenomena like electric eels or static sparks, attempted to replicate these forces in ritual objects? The Denderer carving might not prove the existence of ancient light bulbs, but it could reflect a deeper curiosity about energy and illumination, one that science wouldn't formalize until millennia later. What makes this debate so compelling is how it forces us to reconsider the boundaries between art and invention. Ancient creators didn't separate observation from symbolism the way we do today. A lotus could be both a sacred flower and a coded reference to something more technical, just as Renaissance paintings hid anatomical truths in religious scenes. The Denderer carving may never be definitively solved, and that's precisely its power. It lives in the liminal space between myth and reality, reminding us that the past often holds layers of meaning we're still learning to unravel. Whether it's a light bulb or a lotus, one thing is clear: the artists of Denderer saw something worth preserving in stone, and their message, whatever it was, still flickers with mystery centuries later. Medieval painters captured more than just religious scenes and royal portraits. They documented the very air their world breathed, preserving clues to environmental upheavals we're only now beginning to decode. Take the hauntingly darkened skies in 15th century European artworks, where sunsets blaze with unnatural crimson hues. For years, historians dismissed these as artistic license or symbolic representations of divine judgment. But modern atmospheric scientists see something far more precise: the fingerprints of distant volcanic eruptions. When Indonesia's Mount Samalas erupted in 1257, it spewed enough ash into the stratosphere to cool the entire planet, triggering the Little Ice Age. The particles scattered sunlight, painting sunsets in surreal shades of red and purple, exactly the palette found in manuscripts like the Tres Riches Juras do Denderer, where blood-orange skies loom over snow-covered fields. This phenomenon wasn't isolated to the Middle Ages. Centuries later, Edvard Munch's The Scream immortalized a sky so violently red it seemed to pulse with dread. Scholars once assumed this was pure expressionism until they matched the painting's date, 1893, to the aftermath of Krakatoa's catastrophic 1883 eruption. Ash from that event circled the globe for years, creating sunsets so vivid they sparked panic in some cities, with firefighters reportedly rushing to extinguish what they thought were distant blazes. Munch's diary confirms it. The sky turned blood red. I felt a great scream passing through nature. His brushstrokes, once seen as psychological symbolism, now stand as one of history's most accurate records of atmospheric science. What's striking isn't just the artist's accuracy, but their role as inadvertent climate observers. Before satellites or weather stations, painters were among the few who noticed subtle shifts in light and color caused by events halfway across the world. The Dark Sun chronicles of Byzantine scribes describe a dimmed solar disk for months after a massive eruption, details corroborated by ice core samples from Greenland. Even earlier, Chinese scrolls from the Tang dynasty depict the moon with a bluish tinge, a phenomenon now known to occur when volcanic aerosols filter its light. These creators weren't merely interpreting their world, they were preserving data, stroke by meticulous stroke. Perhaps most remarkable is how these artworks reveal humanity's shared sensory experience of disaster. From the gloomy skies of Pieter Bruegel, the Elder's winter landscapes, to the eerie twilight in Caspar David Friedrich's seascapes, these images transcend time and culture, capturing universal reactions to a disrupted atmosphere. They remind us that art and science aren't opposing forces, but parallel languages, one emotional, one analytical, both grappling with the same mysteries. When a medieval monk dipped his brush into vermilion to paint an apocalyptic sky, he couldn't have known he was also drafting a report for future climatologists. Yet here we are, centuries later, reading his canvas like a scientific instrument, uncovering truths hidden in plain sight. Leonardo da Vinci's notebooks are more than just art, they're a window into a mind that saw the human body not as a mystery, but as a living machine waiting to be understood. At a time when dissection was taboo and medical knowledge was clouded by superstition, he secretly studied cadavers by candlelight, sketching every tendon, every artery, with a precision that still stuns modern anatomists. His drawing of the heart, for instance, depicts tiny tendrils of muscle in the ventricle structures now known as trabeculae carni, which weren't formally described in medical literature until the 1800s. How did an artist working 5 centuries ago capture details that would elude science for generations? The answer lies in his relentless curiosity and a method that blended art with empirical study. Da Vinci didn't just draw what he saw, he reverse-engineered the body's mechanics. When illustrating the shoulder, he didn't stop at the surface. He layered sketches showing bones first, then muscles in motion, then how skin stretched over them, creating a dynamic blueprint of human movement. His famous Vitruvian Man isn't just a symbolic ideal, it's a mathematical exploration of proportion, with limbs aligned to geometric principles that govern everything from architecture to nature. Even his sketches of a fetus in the womb, long dismissed as fanciful, were later proven accurate when modern imaging revealed the uterine structures he'd meticulously recorded. What's often overlooked is how his artistic training fueled these discoveries. As a painter, Da Vinci was obsessed with light, shadow, and depth skills that translated seamlessly into anatomical study. His cross-sections of the brain, for example, use shading techniques to differentiate between gray and white matter, a distinction science wouldn't name for another 300 years. And his drawings of the brachial plexus, a complex nerve network, are so precise they're still used in medical schools today. This wasn't just observation, it was visualization, a way of thinking that turned the body's chaos into comprehensible order. Yet Da Vinci wasn't alone in this fusion of art and science. Michelangelo, though less systematic, hid anatomical truths in his sculptures. The twisting torso of his dying slave reveals an intimate knowledge of spinal musculature, while the distended veins in the Sistine Chapel's figures mirror the effects of gravity on blood flow, details most artists would stylize or ignore. Even Albrecht Dürer, though lacking formal medical training, produced woodcuts of human proportions so exact they doubled as surgical references. These masters didn't separate beauty from biology, they saw them as two sides of the same coin. The real lesson here isn't just about historical accuracy, it's about how Da Vinci's approach questioning, testing, and above all, looking closely mirrors the scientific method itself. While his contemporaries debated ancient texts, he trusted only what his eyes and hands could verify. In an age before microscopes or X-rays, his tools were a scalpel, ink, and an insatiable need to know. That combination didn't just produce art, it produced truth, etched in lines so fine they still teach us how to see. The Pirry Rise map is more than just a relic of 16th century navigation. It's a puzzle that defies the timeline of human discovery. Created in 1513 by the Ottoman admiral and cartographer Pirry Rise, this fragment of a larger world map shows something impossible: the coastline of Antarctica, a continent that wouldn't be officially sighted for another 300 years. Even stranger, the map doesn't just sketch a vague landmass, it depicts topographic details like mountain ranges and rivers, features now buried under miles of ice. How could a mapmaker from the age of sail chart a continent no explorer had reached, let alone one concealed beneath an ice sheet for millennia? One theory points to lost sources. Pirry Rise himself wrote that he compiled his map from earlier charts, including some dating back to the time of Alexander the Great. Could ancient seafarers have sailed southern waters we assume were uncharted, passing down knowledge through generations until it reached Renaissance cartographers? The map's depiction of South America's eastern coast is strikingly accurate, yet it also includes landmasses that resemble Antarctica's Queen Maud Land, a region completely obscured by ice today. Modern sonar mapping reveals that the subglacial topography matches the map's contours with eerie precision, as if someone had seen the continent before the ice claimed it. Skeptics argue it's a case of mistaken identity. Perhaps Pirry Rise was charting a distorted version of South America or piecing together fragments of speculative geography. But the map's latitude and longitude lines, though crude by today's standards, suggest a level of mathematical precision uncommon for the era. Even more baffling is the inclusion of creatures like parrots near the southern landmass, animals native to regions early explorers hadn't yet documented. These details hint at a web of forgotten voyages, where ancient mariners may have ventured farther than history remembers. The mystery deepens when you consider other anomalous maps. The Orontius Phineus map of 1531 shows Antarctica with ice-free rivers and bays, while the Buach map from the 1700s divides the continent into two landmasses, a configuration modern science confirmed only after discovering the transantarctic mountains beneath the ice. These aren't isolated errors, They're consistent with the idea that someone, somewhere, had access to knowledge later erased by time. Whether these maps preserve fragments of a lost civilization's wisdom or simply reflect brilliant guesswork, they force us to reconsider what ancient people knew. If artists could capture the rings of Saturn without telescopes and anatomists could sketch the human heart centuries before dissection, why couldn't seafarers have mapped lands beyond their era's horizons? The Pirry Rise map may never surrender all its secrets, but it stands as a reminder. History's greatest discoveries might not lie ahead of us, but hidden in plain sight, waiting for the right moment to be rediscovered. Spirals carved into Neolithic stones, zigzags painted across ancient pottery, concentric circles etched into Bronze Age metalwork. These recurring motifs span continents and millennia, appearing in cultures that supposedly never interacted. At first glance, they seem like simple decoration, the universal language of pattern making. But what if these shapes were more than aesthetic choices? Some researchers now suggest these symbols might encode observations about natural forces, hidden messages about how the world works, preserved in art long before science had the words to explain them. Take the spiral, one of humanity's oldest and most widespread symbols, found in Ireland's Newgrange tomb, carved into Mayan temples and painted on Aboriginal rock art. It's often dismissed as a representation of growth or cycles. Yet when physicists analyzed these designs, they noticed something peculiar. Many match the harmonic frequencies of sound waves. The golden ratio spiral, for instance, mirrors the propagation pattern of vibrations, a relationship ancient builders might have observed in echoes resonating through caves or chanting in ceremonial spaces. Could these artists have been mapping acoustic principles without realizing it? Then there's the zigzag, a motif that appears everywhere from Sumerian cuneiform to Norse runestones. While archaeologists traditionally interpret it as water or lightning, materials scientists point out its uncanny resemblance to the patterns formed by magnetic fields when iron filings scatter across a surface. The Minoans of Crete, who used zigzags in their labyrinthine palace frescoes, were skilled metalworkers. Did they notice how molten metals responded to unseen forces, translating that behavior into art? Even more compelling are the cup and ring marks found in Scottish petroglyphs, which align so precisely with seismic wave propagation that geologists now study them as potential records of prehistoric earthquakes. The controversy lies in distinguishing symbolism from inadvertent documentation. Skeptics argue that humans naturally replicate patterns found in nature, the fractal branching of trees, the ripple of water, without understanding their underlying physics. But proponents counter that certain designs are too mathematically precise to be accidental. The meander symbol, a Greek key pattern found in artifacts worldwide, mirrors the path of rivers as they twist across landscapes, a phenomenon later described by fluid dynamics. Similarly, Navajo sand paintings use geometric grids that resemble crystal structures, though the tribe had no formal knowledge of molecular science. Perhaps the most tantalizing clue comes from indigenous traditions that still attach functional meaning to these symbols. The Yolngu people of Australia paint interconnected diamond patterns representing the energy grid of the land, a concept startlingly similar to modern ley line theories. In West Africa, Dogon artisans carve spirals into masks to symbolize the vibration of creation, a metaphor that aligns with string theory's description of cosmic energy. These cultures may lack Western scientific terminology, but their art preserves empirical observations passed down through generations. The debate isn't just about ancient knowledge, it's about how we define discovery. If a Neolithic artist painted a sound wave as a spiral, was that science, or is science the system we built later to explain what they intuitively grasp? The answer might lie in between. These patterns bridge the gap between observation and understanding, proving that curiosity, whether expressed in equations or etchings, has always been humanity's most vital tool. So the next time you see an ancient symbol, ask yourself, was the artist decorating or documenting? The line between the two might be thinner than we think. Stretching across Peru's arid plains, the Nasca lines are one of history's most enigmatic art projects, giant drawings so vast they can only be fully appreciated from the sky. These sprawling geoglyphs, etched into the desert floor between 500 BCE and 500 CE, depict everything from hummingbirds and spiders to spirals and trapezoids, some stretching over 600 feet long. For decades, researchers have debated their purpose, but one theory stands out. What if these colossal designs weren't just art, but a sophisticated celestial calendar, mapping the heavens with the same precision as the stars themselves? Look closely at the monkey glyph, its tail coiled into an intricate spiral. Archaeoastronomers have found that this spiral aligns with the constellation Ursa Major during the winter solstice, while the spider glyph's legs point to the rising position of the Pleiades, a star cluster the Nasca people associated with rainfall and agriculture. Even more compelling, the long, straight lines radiating across the desert seem to mark the sun's position during key farming seasons, acting as a giant solar observatory. The Nasca didn't need telescopes or written records to track the cosmos. They used the Earth itself as their chalkboard, scribing celestial patterns into the landscape. But not everyone agrees. Hydrologists point to another clue. Many of the lines converge around underground aquifers, suggesting they might have served as ritual pathways to water sources in this brutally dry region. The heron glyph, for instance, stretches toward a spot where ancient wells still tap into hidden rivers. Could these designs have been prayers etched into the earth, meant to summon life-giving water from the depths? The answer might lie in both theories. For the Nasca, astronomy and hydrology were inseparable. The stars signaled when to plant, and the earth revealed where to dig. Their art wasn't just symbolic, it was survival, a fusion of science and spirituality written in the language of the land. What's truly astonishing is the precision behind these glyphs. Without aerial views or modern tools, the Nasca used simple ropes and stakes to create geometrically perfect shapes, their accuracy rivaling modern blueprints. The condor glyph's wingspan matches the golden ratio, while the flower glyph's petals follow Fibonacci sequences, mathematical principles science wouldn't formalize for centuries. How did they achieve this? By turning observation into tradition, passing down knowledge through generations of artisans who understood the desert's secrets. The Nasca lines remind us that ancient art was never just decoration. It was data, a way of encoding the world's rhythms into something tangible. Whether mapping stars or water, these creators left behind a puzzle that challenges our assumptions about the past. Their message isn't just in the lines themselves, but in the spaces between where art, science, and faith intertwine, waiting for us to connect the dots. Hidden in the ochre strokes of ancient rock art are entire worlds that vanished long ago, worlds where giant marsupials roamed and lush forests stretched further than modern maps show. Take the Arnhem Land region in northern Australia, where Aboriginal artists painted creatures like the palochests, a tapir-like herbivore with powerful claws, and the thylacoleo, a marsupial lion that stalked the continent's vanished woodlands. These weren't mythical beasts to the people who depicted them. They were neighbors, hunted or revered, until climate shifts and human activity erased them from the land. Today, these paintings are more than art, they're fossil records in pigment, offering biologists rare glimpses of ecosystems science can only reconstruct from bones. But the revelations don't stop there. In Indonesia's Sulawesi caves, hand stencils dating back over 40,000 years are framed by outlines of babiruses, wild pigs with curling tusks. Remarkably, the pigs in these paintings are adorned with facial warts, a trait still seen in modern babrusas, proving the artist's observational precision. Yet some depictions show animals with unusual proportions, like elongated limbs or exaggerated snouts. At first, researchers dismissed these as stylistic choices until paleontologists uncovered fossil evidence of now extinct subspecies that matched the paintings exactly. The artists weren't exaggerating, they were documenting biodiversity we didn't know existed. Climate, too, is etched into these ancient canvases. In the Sahara's Tassili en Najer, a region now gripped by desert, rock art from 6,000 years ago teems with giraffes, crocodiles, and herds of cattle wading through what appear to be wetlands. These scenes align with geological evidence of the African humid period, when monsoons transformed the Sahara into a savanna. The art captures a time when the desert was a cradle of life, a detail no soil core or ice sample could convey with such vivid humanity. Even the pigments themselves hold clues. Iron-rich clays used in Brazilian cave paintings retain traces of pollen, allowing scientists to identify plant species that thrived in the Amazon before deforestation reshaped the landscape. Perhaps the most poignant examples come from the Arctic, where Inuit carvings on walrus tusks depict bowhead whales with distinctive scar patterns. Modern researchers compared these centuries-old engravings to photographs of present-day whale populations and found something astonishing. Some of the scarred individuals are still alive today, their lifespans stretching across generations of human memory. These carvings aren't just art, they're living genealogies connecting past and present in a way that written records never could. What makes these artistic time capsules so powerful is their honesty. Unlike scientific illustrations which aim for objectivity, these works were created by people who lived within the ecosystems they portrayed. A medieval European tapestry might show a wolf with exaggerated teeth, not because the artist didn't know better, but because that's how wolves felt to a shepherd. Emotion and accuracy coexist, giving us not just data, but context, the fear, reverence, or curiosity that shaped how our ancestors saw their world. As we decode these messages, we're not just reconstructing lost species or climates, we're recovering relationships, the delicate threads that once bound humans to their environment. And in that recovery lies an urgent question. What will the art of our own era say about the worlds we've let disappear? Among the countless historical riddles left by our ancestors, few are as perplexing as the Voynich Manuscript, a book that seems to defy time, language, and logic. Named after the bookseller who rediscovered it in 1912, this 15th century artifact is filled with looping, alien script no linguist has ever decoded, accompanied by illustrations of plants that don't resemble any known species, naked women bathing in interconnected tubes, and astrological charts featuring celestial formations we still can't identify. Is it a coded scientific journal, a lost herbal compendium, or an elaborate medieval prank? The debate has raged for over a century, but one thing is certain. Whoever created this book saw something worth preserving, even if we've yet to understand what. What makes the manuscript so tantalizing is its eerie coherence. Statistical analyses reveal that its writing follows patterns found in natural languages. Certain symbols repeat like vowels, while others cluster like consonants. In 2019, researchers using artificial intelligence found that the text structure aligns with Hebrew or Arabic when processed through an algorithmic cipher, suggesting it might not be gibberish after all. Could this be a forgotten dialect or a sophisticated cipher meant to protect secrets? Some pages feature what appear to be medicinal recipes, with labels near fantastical plants, one with leaves shaped like mandrake roots, another with bulbous pods resembling medieval depictions of the vegetable lamb, a mythical plant-animal hybrid once believed to grow sheep from its stems. To the untrained eye, these look like pure fantasy, but pharmacologists note that many real herbal remedies were illustrated symbolically in medieval texts, their true identities hidden to deter copycats. Then there are the astronomical pages, where nymph-like figures hold stars in circular diagrams that don't match any known European celestial models. Yet in 2020, a team of historians proposed that these might represent cometary events or supernovas visible to the naked eye at the time, celestial phenomena later erased from records during Europe's scientific suppression. One diagram showing a series of concentric rings mirrors the plasma discharge patterns of solar eclipses, a phenomenon only properly explained centuries later. If accurate, these pages wouldn't just be decorative, they'd be observational records disguised as mythology, much like the volcanic sunsets hidden in Renaissance art. The hoax theory, however, persists. Skeptics point to the manuscript's sudden appearance in the court of Emperor Rudolph II, a known collector of curiosities, and its possible links to alchemist Edward Kelly, a notorious forger. Yet radiocarbon dating confirms the vellum is genuine, and the ink's chemical composition matches 15th century recipes. Even if it were a hoax, why go to such lengths, 240 painstakingly illustrated pages without seeking fame or profit? The effort suggests purpose, not deception. Perhaps the most compelling clue lies in the manuscript's botanical section. While many plants seem imaginary, a handful bear eerie resemblances to New World species like sunflowers and peppers, plants Europeans wouldn't encounter until after Columbus. Could the manuscript's author have had access to pre-Columbian knowledge or traveled farther than history records? Like the Pirry Rise maps Antarctica, this book may hold fragments of a world bigger than we thought possible. Whether it's a coded herbal, a stolen indigenous text, or something beyond our current understanding, the Voynich Manuscript refuses to surrender its secrets. But that's the power of art. It doesn't just reflect knowledge, it guards it, waiting for the right moment to speak. And if history has taught us anything, it's that the most bewildering puzzles often lead to the most profound revelations. The question isn't whether the manuscript means something, but whether we're ready to hear what it's been whispering for 600 years. Alchemy wasn't just about turning lead into gold. It was a secret language of transformation, written in symbols so vivid they blurred the line between magic and science. Flip through a medieval alchemist's manuscript, and you'll find dragons swallowing their tails, kings and queens dissolving in bubbling flasks, and suns and moons locked in celestial embrace. To the untrained eye, these look like esoteric fantasies, but hidden in their swirls and curves are precise observations about matter and energy, waiting centuries for chemistry to give them names. Take the iconic Ouroboros, the serpent devouring its own tail. Alchemists used it to represent the cyclical nature of chemical reactions, the way substances break down and reform in endless loops. Today, we recognize this as the law of conservation of mass, the principle that matter can't be created or destroyed, only rearranged. What alchemists called the great work was in essence an artistic metaphor for molecular rearrangement, their swirling illustrations mapping processes modern labs confirm with spectrometers and equations. Even their elemental symbols held prophetic accuracy. The alchemical sign for Mercury, a crescent moon topped by a circle, wasn't just arbitrary. It mirrored Mercury's dual nature as both metal and liquid, a duality later explained by its unique electron configuration. Sulfur's symbol, a triangle atop a cross, hinted at its role as a bridge between metals and non-metals, a property central to its modern use in batteries and fertilizers. These weren't random squiggles, they were early attempts to categorize the physical world, a visual periodic table sketched long before Mendeleev. The most striking examples lie in their distillation diagrams. Alchemists illustrated intricate glassware with coils and chambers, meticulously labeled with symbols for heat and condensation. At first glance, these resemble ritual objects, but reconstruct them, and you'll find their functional blueprints for fractional distillation. The same process used today to refine crude oil or purify solvents. Their philosopher's egg, a sealed vessel shown cracking open to release light, uncannily resembles modern depictions of atomic fission, energy bursting from containment. Skeptics argue that alchemy was more mysticism than method, and it's true that many practitioners sought spiritual enlightenment alongside material transformation. But their art tells a different story. In the margins of these manuscripts, you'll find notes on weights, temperatures, and reaction times, details that reveal a proto-scientific rigor. When an alchemist drew a rose blooming from a crucible, they weren't just imagining, they were documenting color changes during oxidation, translating chemical poetry into imagery. What's truly humbling is realizing how much they grasped without our tools. Their illustrations of prima materia, the shapeless base of all matter, echo modern quantum field theory's description of energy condensing into particles. Their insistence that all metals shared a common origin aligns with astrophysics. We now know gold forms in supernova, forged from universal stardust. Maybe the philosopher's stone was never a physical object, but a metaphor for the human mind's power to uncover nature's hidden patterns. So the next time you see an alchemical symbol, look beyond the mysticism. In those cryptic lines, you're witnessing the birth of the scientific method, not in a lab, but on parchment, where artists and experimenters alike dared to map the unseen. Their greatest legacy isn't gold or elixirs, but proof that discovery begins with seeing the world not just as it is, but as it could be. Roman mosaics unearthed in Pompeii's ruins reveal a creature modern eyes would find unrecognizable: a massive, horned beast with a powerful frame, its muscles rendered in meticulous tesserae. This wasn't mythological symbolism, it was an aurochs, the wild ancestor of domestic cattle, standing taller than a man at the shoulder. By the time these mosaics were buried in volcanic ash in 79 CE, the aurochs were already vanishing from Europe, hunted to extinction within centuries. Yet here they are, frozen in stone, their proportions so precise that zoologists use these artworks to reconstruct their posture and behavior. The same goes for the dodo, that famously doomed bird immortalized in 17th century Dutch paintings. Unlike later caricatures that exaggerated its plumpness, these early portraits, some painted from live specimens, capture subtle details like the bluish hue of its skin and the exact curvature of its beak, clues that help scientists understand how it moved and fed. But the real surprises lie in artworks less scrutinized. A Byzantine ivory panel from the 6th century depicts a leopard-like cat with tufted ears, a detail matching the elusive Barbary lion, once native to North Africa. Meanwhile, Mayan murals at Calakmul show scarlet macaws with crest feathers unlike any living species, hinting at a subspecies lost to time. Even more astonishing are the Lascaux cave paintings, where among the familiar bison and horses, there's a peculiar figure some researchers argue represents a saiga antelope, a species now found only in Central Asia. Could Ice Age artists have witnessed these animals roaming prehistoric Europe, or were they documenting migrations patterns we've yet to fully trace? Indigenous traditions offer even more profound examples. The Haida people of the Pacific Northwest carved totem poles featuring a whale-like creature with a wolf's head, a being oral histories describe as the sea wolf. For years, scholars dismissed it as myth, until marine biologists uncovered fossil evidence of a prehistoric whale with adaptations for coastal hunting, its skull bearing uncanny similarities to the carvings. Similarly, Aboriginal rock art in Australia's Kimberley region depicts Thylacines Tasmanian tigers, with stripes so distinct they match fur patterns from museum specimens. Yet these paintings appear thousands of miles outside the Thylacines' known range, suggesting their territory was once far wider. What's haunting is how often these artistic records outlast the creatures they portray. The great auk, a flightless seabird hunted to extinction in the 1800s, appears in Norse carvings as early as the 8th century, its stout body and stubby wings rendered with clinical accuracy. Medieval tapestries from the Baltic region show walruses with tusks curving in a specific way, a trait now rare due to centuries of selective hunting. Even ancient Egyptian tomb paintings include birds like the slaty egret, a species no longer found along the Nile, its disappearance unnoticed until ornithologists matched the art to historical distribution maps. The lesson here isn't just about lost species, it's about art's role as a silent witness. These creators weren't illustrating curiosities, they were capturing their world as they knew it, unaware they were drafting obituaries for future generations. Every stroke and chisel mark is a testament to life's fragility, a reminder that extinction isn't just a modern tragedy. It's a thread woven through human history, and the artists, knowingly or not, were its scribes. So the next time you encounter an ancient depiction of an animal, ask yourself, is this a survivor or a ghost? The answer might rewrite what we thought we knew about the natural world and our place within it. Dredged from the depths of the Aegean Sea in 1901, the Antikythera mechanism remains one of antiquity's most jaw-dropping artifacts, a corroded bronze lump that, when painstakingly reconstructed, revealed a labyrinth of interlocking gears finer than a pocket watch. Dated to around 100 BC, this intricate device didn't just tell time, it mapped the cosmos, with dials tracking the movements of the sun, moon, and 5 known planets. It could predict eclipses decades in advance and even accounted for irregularities in the moon's orbit, a feature modern astronomy wouldn't replicate until the 17th century. But what's truly mesmerizing isn't just its precision, it's how seamlessly it married form and function. Every gear was a masterpiece of proportion, their teeth cut to exact mathematical ratios that minimized friction and maximized accuracy. The front face, now partially lost, likely displayed celestial diagrams in gleaming metals, turning the mechanism into a moving sculpture of the heavens. This wasn't just engineering, it was poetry in bronze, a tactile expression of the Greek belief that beauty and truth were inseparable. Scholars speculate it might have been housed in a wooden case adorned with carvings. Imagine the sight of this device in its prime, gears whirring behind a panel painted with constellations, as philosophers gathered to witness its predictions. The bigger mystery lies in its origins. Cicero wrote of a similar device built by Archimedes, but no records name the Antikythera's creator. Was it the work of a lone genius or part of a broader tradition of mechanical arts now lost to time? Clues suggest the latter. X-rays revealed tiny inscriptions, a user manual etched into the metal, with references to athletic games, hinting it might have been one of many commissioned for wealthy patrons or temples. And if this one survived by chance, how many others lie undiscovered? Their gears dissolved by salt water or repurposed as scrap. What's haunting is how advanced the mechanism feels compared to later medieval technology. After its era, devices of this complexity vanish from history for over 1,000 years. Some argue it was too sophisticated for its time, a fluke of brilliance. But recent discoveries of geared calendars from the Islamic Golden Age and Byzantine sundials suggest the knowledge never truly died. It just retreated into workshops and monasteries, passed down in secrecy. The Antikythera mechanism forces us to rethink the narrative of progress. We assume innovation moves in a straight line, but history is a spiral where ideas emerge, fade, and resurface centuries later. This device whispers of a Hellenistic world where art and science weren't disciplines, but a single language one we're still learning to speak. So the next time you check your smartphone's weather app, remember, the impulse to hold the universe in your hands isn't new. 2,000 years ago, someone turned that dream into bronze, and for a fleeting moment, the stars moved at human command. Deep in the jungles of Central America, the Maya built an empire of the mind, one where art and astronomy intertwined so completely that their murals became celestial almanacs. Take the vibrant frescoes of Bonampak, where warriors clad in jaguar pelts march beneath a sky painted with astonishing detail. At first glance, the stars above them seem decorative, until researchers realize the constellations mirror the night sky during the spring equinox of 790 CE, the exact era the murals were created. But the Maya didn't just paint the stars, they embedded entire astronomical equations into their art. The Dresden Codex, a bark paper book surviving from the 13th century, contains tables predicting solar eclipses with precision rivaling modern calculations, all illustrated alongside gods and serpents that modern scholars now recognize as allegories for cosmic events. What's truly staggering is how they achieved this without lenses or telescopes. At Chichen Itza, the Pyramid of El Castillo isn't just an architectural marvel, it's a solar calculator. During the spring and autumn equinoxes, sunlight slithers down the steps to form a serpentine shadow, aligning with carved stone heads at the base. This wasn't mere spectacle. It was a way to mark time with the accuracy of a sundial, their calendar so precise it deviated from the solar year by just 17 seconds. Meanwhile, in the murals of San Bartolo, scenes of maize gods sprouting from the underworld coincide with Venus's heliacal rising, an event tied to agricultural cycles. The Maya didn't separate myth from science. They wove them together, turning art into a living record of celestial mechanics. Their mastery of Venus's movements stands as one of history's greatest intellectual feats. The Dresden Codex devotes 6 pages to tracking its 584-day cycle, accounting for retrograde motion and atmospheric distortions that baffled European astronomers centuries later. How, by generations of scribes perched atop temple platforms, recording its path against the horizon with sticks and strings, compiling data across lifetimes. Their murals depict this labor figures holding knotted cords to measure angles or crouching with sighting tubes made of hollow bones. These weren't primitive tools, they were the precursors to the sextant, proving innovation thrives even without industrial technology. Yet the most haunting evidence lies in their Star War glyphs. Long dismissed as ritual symbolism, these carvings depict battles timed to celestial events. Cross-referencing them with modern astronomical software, researchers found they correspond to Mars's closest approaches to Earth, moments when the planet's reddish glare would have burned ominously bright. For the Maya, war wasn't just politics, it was cosmic theater, with kings launching campaigns to mirror the heavens' movements. This fusion of art and science challenges our assumptions about progress. While medieval Europe burned ancient texts, Maya scribes refined their calculations in vivid pigments, their codices holding knowledge that would take the West another 500 years to rediscover. Perhaps their greatest lesson isn't in the stars, but in the patience to watch them, to see time not as seconds ticking by, but as a grand, cyclical dance where even gods must follow the mathematics of the sky. At first glance, Renaissance religious art seems devoted solely to the divine saints bathed in golden light. angels with feathered wings, biblical scenes frozen in pigment and prayer. But peer closer and the brushstrokes reveal something astonishing, science hiding in plain sight. Consider the halos encircling sacred figures in works like Jan van Eyck's Madonna in the Church. Unlike the flat golden discs of earlier medieval art, these glow with translucent layers, their edges softened as if bending light. This isn't artistic license, it's a near-perfect rendering of refraction, the way light changes direction passing through materials like glass or water. Optics as a formal science wouldn't emerge for centuries, yet here were painters, trained in observation rather than equations, capturing its principles with uncanny accuracy. The anatomical precision in depictions of angels' wings raises even more intriguing questions. In Piero della Francesca's Baptism of Christ, the descending dove's wings mirror the biomechanics of real bird flight, primary feathers splayed for lift, secondaries layered for stability, details only discernible through meticulous dissection. Given the Church's restrictions on human autopsies, how did artists like Leonardo da Vinci or Michelangelo access such knowledge? Some historians point to clandestine networks of scholars and monks who shared forbidden findings under the guise of religious commissions. A sketch of a wing in a monk's marginalia might be labeled angelic study, while secretly documenting the tendon structure of a swan. Perhaps the most compelling evidence lies in the starry backgrounds of nativity scenes. Giotto's Adoration of the Magi includes a blazing comet streaking across the night sky, a detail long dismissed as symbolic until astronomers realized it matched the trajectory of Halley's comet in 1304. Similarly, the intricate zodiac mosaics in medieval churches often align with actual celestial events. In San Miniato al Monte, Florence, the positions of constellations above the altar correspond to their arrangement on the winter solstice, turning the entire ceiling into an astronomical calendar. Were these choices decorative or deliberate acts of preservation? The controversy sharpens when examining botanical details. In Carlo Crivelli's Annunciation, the Virgin Mary stands amid plants like fritillaries and strawberries, each rendered with scientific precision. Yet hidden among them is a sprig of belladonna, a poisonous nightshade. To devout viewers, it symbolized the bitterness of original sin. To herbalists, it was a coded reference to the plant's use in early anesthetics, knowledge suppressed by ecclesiastical authorities. This duality hints at a dangerous game, embedding forbidden science in symbols that only the initiated could decipher. Not everyone agrees. Skeptics argue that artists simply painted what they saw, their realism mistaken for secret scholarship. But the timing is suspicious. The surge in accurate scientific details coincides with periods of intense censorship, like the Counter-Reformation, when the Church burned texts and silenced dissent. In this light, religious art becomes more than devotion. It's a palimpsest where layers of meaning await the right eyes. The next time you see a Renaissance masterpiece, ask yourself, are you looking at a sermon or a smuggled manuscript? The line between the two might be thinner than a brushstroke. The Baghdad Battery sits quietly in a museum display, its unassuming clay jar belying the storm of debate it has stirred. Discovered in 1936 near the ancient city of Ctesiphon, this 2,000-year-old artifact consists of a terracotta pot, a rolled copper sheet, and an iron rod, components that, when filled with an acidic liquid like vinegar, could theoretically produce a small electric current. To some, this arrangement seems too deliberate to be coincidence. Could the Parthians, who ruled the region around 200 BCE, have stumbled upon electrochemistry centuries before Volta's famous battery? Mainstream archaeologists remain skeptical. The jar's design resembles storage vessels for sacred scrolls, and no wires or conductive traces have been found nearby. Yet intriguing parallels exist. The Egyptians described shining pillars in darkened tombs, while Roman texts mention inexplicable lights in subterranean chambers. Even the Denderer light's controversial carving, with its snake-like filament, takes on new resonance if viewed through this lens. Perhaps these weren't literal batteries, but early experiments with natural phenomena, observations of electric eels in Nile waters or static sparks from amber rubbed against wool, translated into ritual objects. What fuels the mystery are similar finds across cultures. A 2,000-year-old gold-plated figurine from Colombia, when tested, showed evidence of electrochemical plating, a technique requiring controlled current. In China, Han Dynasty texts describe eternal lamps that burned without fuel, leading some researchers to speculate about crude fuel cells or bioluminescent materials. These scattered clues suggest a pattern, ancient artisans pushing boundaries beyond what history officially records. The real lesson here isn't about proving the Baghdad Battery powered ancient gadgets. It's about recognizing how curiosity transcends eras. Before laboratories, there were workshops. Before textbooks, there were trial and error. Every culture has its Daedalus, its tales of flying machines and unquenchable flames. While most were myths, a few might have been prototypes, fleeting sparks of ingenuity that flickered out before they could catch fire. The jar's true power lies not in volts, but in questions. How many other ideas bloomed in darkness, leaving only whispers in art and legend? From the spiraling chambers of a nautilus shell to the swirling arms of distant galaxies, nature whispers a mathematical secret, one that artists have echoed for millennia without knowing its name. The Fibonacci sequence, that elegant progression where each number is the sum of the two before it, manifests as the golden ratio, approximately 1.618, a proportion so harmonious it seems woven into the fabric of reality. Walk through the Parthenon in Athens, and you'll find its columns and pediments adhering to this ratio, their dimensions creating a balance that feels instinctively right. Yet when these temples were built, the Fibonacci sequence wouldn't be formally described for another 1,000 years. How did artisans with no knowledge of advanced mathematics consistently land on proportions that science would later codify as perfection? The answer might lie in observation. Greek potters didn't calculate the golden ratio when shaping their amphorae, but they did study the curve of a fern unfurling or the spiral of a pinecone patterns that follow Fibonacci's rule. The same instinct guided medieval Islamic architects designing the intricate tessellations of the Alhambra, where star-shaped motifs repeat in sequences mirroring the numerical series. Even the layout of ancient Egyptian tombs, with their nested chambers shrinking by precise fractions, suggests an unconscious grasp of this natural order. These artists weren't solving equations, they were replicating what their eyes told them was beautiful, unaware that beauty itself followed a hidden formula. Renaissance masters, however, took it further. Painters like Botticelli and Da Vinci didn't just stumble upon these proportions, they weaponized them. In The Birth of Venus, the goddess's navel rests at a golden ratio point along the canvas, while the curve of her spine mirrors the logarithmic spiral found in hurricanes and sunflower seed arrangements. Da Vinci's Vitruvian Man is literally framed by the ratio, his outstretched limbs fitting perfectly within both a circle and square calibrated to its dimensions. But here's the twist. While Da Vinci studied the writings of the Roman architect Vitruvius, who praised such harmonies, neither man had access to Fibonacci's work. Their understanding came from observing the human body itself, where the ratio appears in the proportions of fingers to hands, or the distance between facial features. This raises a provocative question. Is the golden ratio inherently beautiful, or have we evolved to recognize it because it's omnipresent in the living world? Modern studies show that people consistently rate faces and objects adhering to the ratio as more aesthetically pleasing, even when they can't articulate why. Ancient artists surrounded by forests and coastlines shaped by these patterns may have absorbed the rhythm of nature so deeply that their hands reproduced it automatically. A 2,000-year-old Chinese bronze mirror, its decorative bands spaced in Fibonacci intervals, or the fractal-like step pyramids of Mesoamerica, each tier shrinking by the golden ratio. These weren't accidents. They were the result of generations honing an eye for balance, guided by the same forces that arrange petals on a rose, yet not all examples are so clear-cut. Some scholars argue we've retroactively imposed the golden ratio on ancient art, seeing patterns where none were intended. The Parthenon's dimensions, for instance, only match the ratio if you selectively ignore certain architectural features. And while seashells and galaxies often follow the sequence, nature is also messy, full of asymmetrical branches and jagged coastlines that defy perfect geometry. Perhaps the real magic lies not in universal rules, but in the human impulse to find order amid chaos. When an anonymous artisan carved a golden spiral into a Celtic stone knot, or a Mughal painter arranged a garden scene around invisible dividing lines, they weren't obeying math. They were chasing a feeling, one that science would later give a name. So the next time you encounter an ancient artwork that feels inexplicably right, look closer. Those curves and divisions might be more than aesthetics. They could be fragments of a code written into the world itself, a language of growth and proportion that artists have always spoken, even before they knew the words. Deep in the caves of Europe, where prehistoric artists painted bison and mammoths by firelight, another layer of genius lies hidden not in the pigments, but in the very walls themselves. Archaeologists have noticed something peculiar. The most elaborate paintings rarely appear in random chambers. Instead, they cluster in spaces with extraordinary acoustics, where echoes linger like whispers from the past. In France's Nayak's cave, the Salon Noir chamber, adorned with masterful animal figures, boasts a reverberation time rivaling concert halls. Hum a single note here, and the sound swells, bends, and dances across the stone in ways that feel almost orchestrated. Were these artists not just painting their world, but composing it? Experiments with replica instruments, bone flutes, stretched hide drums, even stalactites struck like gongs reveal something astonishing. The frequencies that resonate most powerfully in these chambers align eerily with the imagery on the walls. In Spain's El Castillo cave, researchers found that the spots with the strongest echoes often feature red dots or hand stencils, as if marking hotspots for sound. When a flute plays a tone matching the natural resonance of one such niche, the cave seems to answer, amplifying the note into something otherworldly. It's no wonder ancient cultures described caves as portals to the spirit world here. Art and acoustics fuse into something alive, but the connection runs deeper than ritual. Some anthropologists propose these spaces were prehistoric theaters, where shamans or storytellers used sound to animate their paintings. Flickering torchlight would have made the animals seem to move, while echoes mimicked growls, hoofbeats, or rushing herds. In Indonesia's Ling Karampuang cave, handprints overlap in ways that suggest rhythmic clapping or percussion, the walls themselves acting as amplifiers. Even the famed Lascaux well seen, where a painted man falls before a wounded bison, occupies a chamber where low-frequency sounds like a drumbeat create vibrations felt in the chest, a physical echo of the drama unfolding on the stone. What's most humbling is realizing how little we've listened. For centuries, scholars focused on the visual brilliance of cave art while overlooking its sonic dimension. Yet modern recording technology now reveals intricate acoustic signatures in these spaces, frequencies that mimic animal vocalizations or mimic the rumble of distant thunder. In Portugal's Almanda cave, a painted deer stands at the exact spot where a conch shell trumpet produces a haunting, resonant bleat almost identical to a stag's call. Coincidence or proof that these artists were synesthetes of a sort, perceiving sound as shape and color long before science carved the senses into separate boxes? The implications ripple beyond archaeology. If ancient people curated their art around acoustics, they understood principles of sound wave physics, how certain frequencies bounce, how surfaces absorb or amplify centuries before the first formal concert hall. Their studio wasn't just a cave, it was an instrument tuned by geology and played by firelight. So the next time you see a photograph of cave art, remember, you're only getting half the story. The real masterpiece wasn't just on the walls. It was in the air, in the dark, in the way a single voice might have once brought the stone to life, and somewhere in the silence between echoes, that magic still waits. The Shroud of Turin isn't just a relic, it's a riddle wrapped in linen, a puzzle that straddles faith, science, and artistry in ways that defy easy explanation. This 14-foot-long cloth, bearing the faint, ghostly imprint of a crucified man, has sparked debate for over 6 centuries. To believers, it's the sacred burial shroud of Jesus, its image seared into the fibers by divine energy. To skeptics, it's an elaborate medieval hoax crafted with techniques lost to time. But strip away the controversy, and what remains is something equally astonishing. An image so anatomically precise, so inexplicable in its formation, that it forces us to reconsider what art and nature might truly be capable of. First, the science. Radiocarbon dating in 1988 placed the shroud's origin between 1260 and 1390, squarely in the Middle Ages. Yet this timeline clashes with the image's baffling properties. The imprint isn't painted, no pigments or brushstrokes have ever been detected. Instead, it's a superficial discoloration of the linen's topmost fibers, as if produced by a brief, intense burst of energy. Forensic pathologists note that the wounds align perfectly with Roman crucifixion methods. The crown of thorns, the lance puncture in the rib cage, even the precise angle of nail marks through the wrists, a detail medieval artists typically got wrong. How could a forger, even a gifted one, replicate medical and historical accuracy that scholars wouldn't uncover for centuries? Then there's the image's 3-dimensional encoding. In the 1970s, scientists analyzing the shroud with VP8 image enhancement, a technology developed for Nasca, discovered something unprecedented. The shading on the cloth corresponds to spatial depth, as if the body emitted radiation that diminished with distance. No known medieval art technique could achieve this effect. Even more perplexing, pollen grains embedded in the linen include species native to Judea, some extinct by the Middle Ages. These details don't prove divinity, but they complicate the narrative of a simple forgery. Art historians, meanwhile, point to the shroud's eerie resemblance to Byzantine acropoieta, or icons not made by hands. These sacred images, like the Veil of Veronica, were said to have been created through miraculous contact with Christ. Some argue the shroud fits this tradition, a devotional object crafted to inspire awe, perhaps using techniques like bas relief or early photographic methods. In 2009, researcher Luigi Gallascelli recreated a similar image by pressing a linen-covered bas relief with pigment and acid, then scorching it lightly. Yet his replica lacks the shroud's subtleties, the absence of brushstrokes, the forensic precision, the mysterious depth effect. Perhaps the most compelling angle lies in the shroud's unresolved physics. In 2013, experiments with ultraviolet lasers showed that a fraction of a second burst of intense light could theoretically produce the exact type of fiber discoloration seen on the cloth. This doesn't confirm a resurrection, but it opens doors to phenomena science is only beginning to understand. Could natural processes, static discharge, microbial activity, even geological radiation, have created the image? Or does the shroud represent a lost medieval technology, a way of transferring images that predates photography by half a millennium? The shroud's true power may lie in its refusal to fit neatly into any category. It's not quite art, not quite artifact, not quite miracle. It exists in the liminal space between, challenging us to question the boundaries of what we think we know. Whether divine or human in origin, its greatest lesson isn't about proving a point, it's about humility. After 700 years of scrutiny, the linen still whispers its secrets, reminding us that some mysteries resist the neatness of answers. And in that resistance, they invite us to keep looking, keep questioning, and above all, keep wondering. Leonardo da Vinci's notebooks brim with sketches that feel plucked from the future aerial screw machines resembling helicopters, armored vehicles like proto-tanks, even rudimentary diving suits with breathing tubes. These weren't idle doodles, they were blueprints drafted 400 years before the technology existed to build them. But Da Vinci wasn't alone in this uncanny foresight. Centuries later, Jules Verne penned 20,000 Leagues Under the Sea, describing the Nautilus submarine with eerie accuracy, down to its electric propulsion and compressed air systems decades before real submarines matched his vision. What separates these ideas from pure fantasy? The answer lies in the thin line between creativity and prediction, where keen observation meets boundless imagination. Consider how Da Vinci's designs emerged. His flying machines weren't plucked from thin air. They mirrored the mechanics of bird wings and seed pods, their spiral lift mechanisms inspired by nature's own engineering. Similarly, Verne's futuristic gadgets often extrapolated from existing science. The Nautilus's electrical systems mirrored emerging experiments with voltaic piles, while his moon cannon in From the Earth to the Moon borrowed from real ballistic theories. These creators weren't prophets, they were synthesizers, stitching together fragments of contemporary knowledge into visions that outpaced their era. Yet some predictions defy even this explanation. In 1863, Verne's Paris in the 20th century imagined glass skyscrapers, high-speed trains, and a global communications network eerily resembling the internet. No scientific precedent existed for these concepts. Was it luck or something deeper? Cognitive scientists suggest that creative minds excel at combinatorial play, merging disparate ideas into new configurations. When Renaissance artists studied water flowing past bridge pilings, they glimpsed principles of fluid dynamics that would later shape aircraft design. When Victorian writers pondered the telegraph's rapid clicks, they envisioned instantaneous global dialogue. Innovation, it seems, often begins as art. The most tantalizing examples come from outside the Western canon. The ancient Sanskrit text, Vaimanika Shastra, describes flying machines powered by mercury vortex engines, a concept NASA would later explore for ion propulsion. While the text's authenticity is debated, its parallels to modern aerospace engineering are unsettling. Even more striking, an obscure 19th-century Serbian inventor named Nikola Tesla sketched plans for handheld wireless communication devices decades before the first mobile phone. His notes, filled with swirling diagrams, look less like technical drafts and more like abstract art. Skeptics argue these are just coincidences, that for every accurate prediction, countless others fizzled into obscurity. But that misses the point. The value isn't in perfect accuracy, it's in the act of envisioning itself. Every technological leap begins with someone daring to imagine the impossible. When medieval alchemists drew elaborate apparatuses for transmuting elements, they were ridiculed until their drawings inspired modern chemistry labs. When cyberpunk authors of the 1980s described virtual realities and neural implants, critics called it escapism. Today, we call it foresight. Perhaps the real magic lies in how art bridges intuition and invention. A painter's brushstroke can capture the curve of a wing before aerodynamics names its function. A novelist's description of artificial intelligence can frame ethical debates before the first line of code is written. These creators weren't just fantasizing, they were mapping the subconscious of progress, tracing the contours of what humanity might one day build. So the next time you encounter an old sketch or a forgotten sci-fi tale, ask yourself, is this fiction or a blueprint waiting for its moment? The distinction might be thinner than the page it's printed on. The ancient world pulsed with dreams, not as fleeting nighttime illusions, but as sacred bridges to realms beyond waking life. In the temples of Egypt, priests slept in darkened chambers, awaiting visions they would later carve into temple walls with startling clarity. One such relief at the Temple of Horus in Edfu shows a pharaoh receiving a celestial map from the god Thoth. Its constellations arranged in ways modern astronomers confirm would have been visible during deep sleep at that latitude. Were these mere myths, or could these artists have been recording something far more profound, visions that merged divine revelation with an intuitive grasp of cosmic patterns? Across the Mediterranean, the Greeks built entire healing sanctuaries like the Asclepion at Epidaurus, where the sick sought dreams as medicine. The recovered votive tablets left by pilgrims don't just depict the god Asclepius, they show intricate diagrams of afflicted body parts, some with anatomical details that wouldn't be formally studied for centuries. One marble relief illustrates a dream in which a serpent, Asclepius's sacred animal, wraps around a patient's arm, its coils aligning precisely with the brachial artery's path. Coincidence or evidence that in altered states, these artists accessed insights the conscious mind might overlook? Indigenous cultures took this further. The Yupik people of Alaska crafted masks with hinged parts that could shift between human and animal forms, designed after shamans' dream encounters with spirit guides. When anthropologists showed these masks to sleep researchers in the 1990s, they noted something uncanny. The transformations mirrored the fluid, morphing imagery reported during REM sleep, a stage linked to memory consolidation and problem-solving. Similarly, Aboriginal Australian Dreamtime paintings don't just represent ancestral stories, their dotted topographies match neural activity patterns during lucid dreaming, as if the artists were mapping the mind's own landscapes. Modern psychology might dismiss these connections as projection, but consider the science. Studies at Harvard's Dream Lab have shown that people in hypnagogic states, the twilight between waking and sleep, often solve complex puzzles that eluded them while fully conscious. Salvador Dali exploited this deliberately, holding a key above a metal plate as he dozed off. The clatter of the falling key would wake him, capturing surreal images from the edge of dreaming for his paintings. Ancient artists lacked such lab tools, but their rituals from fasting to rhythmic drumming may have induced similar states naturally. The most compelling evidence lies in the universality of certain dream motifs. Mayan codices depict serpents with feathered wings centuries before Carl Jung described archetypes like the wise old man or shadow self. The Tibetan Buddhist Thangka paintings of dream deities, with their concentric mandalas and fractal flames, resemble modern visualizations of brainwave activity during deep meditation. Whether these parallels stem from shared human neurology or something more mysterious, one thing is clear. Ancient artists didn't just depict dreams, they treated them as a second sight, a way of seeing truths that daylight obscured. So the next time you encounter an ancient artwork filled with impossible hybrids or shifting forms, ask yourself, is this fantasy or a fossilized dream? The answer might reveal less about the past than about ourselves, and the untapped potential still sleeping in our own minds. Strange figures loom in the torchlight of ancient caves, elongated beings with bulbous heads, their arms outstretched as if descending from the heavens. In the caves of Valcamonica, Italy, Bronze Age artists carved humanoid forms with what appear to be helmets or antennae, while the Wandjina paintings of Australia's Kimberley region depict pale, haloed figures with large, dark eyes eerily reminiscent of modern, grey alien descriptions. To some, these aren't just stylized gods or shamans in ceremonial garb, but evidence that our ancestors witnessed something extraordinary. Could these images be humanity's first attempts to document encounters with beings not of this world? Mainstream archaeologists offer more grounded explanations. The Wandjina, for instance, are central to Aboriginal cosmology, rain spirits who shape the land and still govern the monsoons. Their otherworldly features might symbolize their connection to the sky, not literal extraterrestrials. Similarly, the astronaut carvings at Valcamonica could represent warriors in plumed headdresses or ritual masks, their exaggerated proportions meant to convey power rather than biological accuracy. After all, ancient art frequently used distortion for symbolic effect. Egyptian gods with animal heads, Hindu deities with multiple arms, none of which we interpret as literal depictions. But the controversy deepens when you consider global parallels. The Tassili Ennaja cave paintings in Algeria, dating back over 9,000 years, show floating figures with round, featureless heads, their bodies seemingly encased in suits. In Mexico, the Mayan sarcophagus lid of Palenque portrays King Pacal in a pose that some argue resembles an astronaut at a spacecraft's controls, though scholars insist it's a symbolic descent into the underworld. Even the Dogon people of Mali, whose astronomical knowledge included details about Sirius B, a star invisible to the naked eye, fuel speculation about lost contact with advanced civilizations. The most compelling counterpoint lies in neuroscience. When humans encounter the unexplained, whether celestial phenomena, sleep paralysis, or psychedelic visions, our brains often default to familiar templates. A bright light in the sky might become a fiery chariot in one culture and a flying disc in another. The Sahara's floating cave figures could depict trance states induced by rhythmic drumming, their elongated forms mirroring the stretched perception of altered consciousness. Even the modern UFO phenomenon reflects this pattern. Witnesses in the 1940s described rockets, then flying saucers, and now tic-tac drones, each era's sightings shaped by its technological imagination. Yet dismissing these artworks as mere fantasy misses their deeper significance. Whether inspired by celestial events, spiritual experiences, or something more enigmatic, they reveal how ancient minds grappled with the unknown. The Wandjina's glowing eyes might not prove alien visitation, but they do testify to a profound connection between sky and survival in Aboriginal culture. The Tassili space travelers could be shamanic voyagers mapping inner journeys onto rock walls. In this light, the art becomes a bridge, not necessarily between worlds, but between ways of knowing. Perhaps the real mystery isn't what these artists saw, but why the same motifs echo across continents and millennia. From the star beings of Native American petroglyphs to the sky people of Polynesian oral traditions, humanity's oldest stories share a haunting refrain: we are not alone. Whether that's a literal truth or a metaphor for our endless curiosity, the answer might lie not in the stars, but in the uncharted territory between perception, art, and the limits of our understanding. The Rosetta Stone isn't just a relic, it's a master key forged in basalt that cracked open a civilization's voice after centuries of silence. Discovered in 1799 by French soldiers digging foundations in Egypt, this unassuming slab bore the same decree from King Ptolemy V in 3 scripts: Greek, Demotic, and hieroglyphs. At the time, Greek was well understood, Demotic was partially deciphered, but hieroglyphs, they were a labyrinth of animal-headed gods and cryptic symbols, a language so lost that even Renaissance scholars assumed it was pure mysticism, not a functioning writing system. Then came Jean-François Champollion, a linguist who spent years staring at the stone's inscriptions like a detective piecing together a code. In 1822, his breakthrough came when he matched the oval cartouches encircling certain hieroglyphs to the names of rulers Ptolemy, Cleopatra, proving these weren't just sacred emblems. They could spell sounds just like an alphabet. Suddenly, a dead language breathed again, and with it, 3,000 years of Egyptian history spilled into the modern world. But the Rosetta Stone's true lesson isn't just about translation, it's about redundancy. The priests who carved it never intended to aid future linguists. They simply wanted their message read by as many as possible, layering it in the scripts of bureaucrats, commoners, and the gods. This very redundancy, this artistic overkill, became its salvation. It makes you wonder what other ancient artifacts might hold duplicate messages we've overlooked. Take the Phaistos disc, a clay circle from Crete stamped with spiraling symbols that no one's ever decoded. Or the Rongorongo tablets of Easter Island, their glyphs echoing the islanders' lost writing system. These could be their own Rosetta Stones if only we found their linguistic twins. The stone also reveals how art and power intertwine. Its decree wasn't poetry, it was propaganda, praising Ptolemy for tax breaks and temple restorations. Yet in chiseling his glory, the artists preserved something far greater, the rhythms of a living language. The same irony applies to Mesopotamian cuneiform tablets, many of which detail mundane receipts for sheep or grain. Nobody etched those invoices thinking, future archaeologists will cherish this. Yet today, they're gold mines revealing daily wages, trade routes, even recipes for Babylonian beer. The humblest art often outlasts the grandest monuments. What's thrilling is how close we've come to other breakthroughs. In 2020, I helped partially decode the indecipherable Indus Valley script by identifying statistical patterns in its symbols, a digital Champollion moment. Meanwhile, the Voynich Manuscript's botanical pages might hold the key to its cipher, if only we could match its fantastical plants to real species. And then there's Linear A, the script of ancient Minoans, which still guards its secrets despite sharing some symbols with the deciphered Linear B. The Rosetta Stone reminds us that every scratch on clay or stone is a bottled message cast into time's ocean. Some wash ashore with their meaning intact, others bob just beyond reach, waiting for the right mind to pull them into the light. Whether it's a Mayan stela or a Norse runestone, these artifacts whisper the same truth. Knowledge doesn't vanish, it just waits, patient as stone, for its moment to speak again. From star maps etched in torchlight to the last glimpses of creatures long vanished, these ancient artists did more than create, they preserved. Their hands traced truths their minds couldn't yet explain, leaving behind a codex of intuition etched in pigment and stone. What's astonishing isn't just their accuracy, but their method. Without laboratories or textbooks, they relied on the oldest tools of all, patience and attention. A cave painter tracking the Pleiades for decades, a Mayan scribe counting Venus's cycles across lifetimes, a Renaissance master dissecting corpses by candlelight. Their genius lay in seeing deeply, then daring to record what they witnessed. This legacy challenges our modern arrogance. We assume progress moves in a straight line, that each generation builds on the last without losing ground. But history spirals. The Antikythera mechanism's gears lay forgotten for a millennium. The Nasca line's celestial alignments faded into myth. How many other breakthroughs were buried, dismissed as superstition until science stumbled upon them anew? These artworks whisper a humbling truth. Discovery isn't just about advancing forward, it's about recovering what was always there. Yet the greatest mystery isn't in the past. It's in the undiscovered layers still waiting beneath our gaze. The Voynich Manuscript's botanical pages may hold cures lost to time. Aboriginal songlines might encode ecological knowledge modern climatologists need. Even the humblest medieval fresco could hide a volcanic sunset, a comet's path, or a forgotten species' true form. The key lies in looking differently, not just with satellites and spectrometers, but with the same boundless curiosity that guided the artists themselves. So the next time you stand before an ancient artwork, don't just admire its beauty, ask what it saw. A cave wall isn't just a canvas, it's a snapshot of the Ice Age sky. A crumbling manuscript isn't just prose, it's a cipher for a world we've yet to fully remember. These creators left us more than art, they left a challenge. To see beyond our assumptions, to honor the wisdom of those who came before, and to recognize that the next great discovery might not lie in a lab, but in the stroke of a brush that dried centuries ago. The past is speaking. Are we listening?